are busy with sum to infinity this time, and you knew that it was sum to infinity because the sum starts off saying, find this. So I'm saying minus 1 and minus 1, minus 2, minus 1, minus half, minus a quarter, etc. I'm going to add all of the next stuff to the previous stuff. So this means I'm reading, I should get the sum to infinity. Okay, sum to infinity can only be found if R
is between negative 1.
negative 1 and positive 1. What is my R?
It's positive a half.
Is a half.
Or negative.
How do I know that? Minus 1 divided by minus 2 is positive a half. Minus a half divided by minus 1 is positive a half. Or is truly or positive a half. And A?
Negative
2, because my sum to infinity formula is
A over 1.
A over 1 minus R. So I have A is negative 2, R is
1 minus a half.
positive a half there. And what's your answer be?
Negative 4.
Negative 4. Does it make kind of sense?
Yes, it does.
If I do the sum to infinity, instead of the negative 2 that you add to negative 1 giving me negative 3, negative 3 and a half, negative 3 and 3 quarters, and it's going to come lesser, 3 and something lesser,
Answer negative 4.
tending to be negative 4.
Yes, ma'am.
Sounds kind of right. Okay, number F. Also, the question says find.
Right.
So the question says find
Sum of
sum to
infinity.
infinity. Right, sum to infinity. But before you go on, when you see this, you write down the series, which starts where? Where k is equal to 1. How many terms are here, please? Infinity. You don't have to say infinity minus 1 plus 1, it's infinity.
Ma'am, K is 3.
Was this a 3? Thank you. So, if it's a 3, is there less numbers? Sum of how many terms? It's still infinity. If you take 2 away, it's still infinity. You can't take 2 away, but you're not infinity anymore. It's going to be from 3 up to infinity. But the first term then is when k is substituted with 3. And that answer there would be negative
1 over 8.
Okay, next one. If I substitute it with a 4,
Plus 1 over 16.
plus, excellent. Because I have a negative to an even exponent in here, positive. The third one would be where k is 5, and that would give me
Negative 1 over 32.
and I think you can see the pattern going here. Where my A is
Negative 1 over 8.
negative 1 over 8, and my R is
Negative a half.
negative. It has to be negative, and the only time that a term sequence can go plus, minus, plus, minus, plus, minus is if there's a R. That's negative, making it first plus, then minus, then plus, then minus. And it is a half. And because it's something between 1 and minus 1, between 1 and minus 1, that's why this is going to be a converging sequence that I can get the sum to infinity of. So sum to infinity would be A over
1
1 minus R. So it's negative 1 over 8 over 1 minus minus a half. And please give me an answer.
Negative 1 over 12.
Does it sound right? It's very, very small things that gets added, and then I add a little bit, and I take away a little bit, and I add a little bit, and I take away a little bit. Just thinking, if this answer was something like minus 4, I
Doesn't
would
make
have thought,
sense.
I don't know. Okay, just logic. Next one also says, find this. So I'm saying find sum to infinity. Is there less or more numbers from 0 to infinity?
No.
It's still infinity. First thing you write down is your
Series.
series. What does your series look like?
5 plus 1
So that's going to be 0, right? So it's just 5.
plus
Then you go 1, then it's 0. 0.
It's 1.
How come 1? Because there's the power 1 there. 1 minus 1 is 0, and anything to the power 0
is 1.
well, not anything, right? There's no
It's
0
4.
to the 0. And then the next one, if it's 2, then it's 5 to the negative 1. And 5 to the negative 1
1 over 5.
is 1 over 5. And we're getting a series because we're summing all of them, adding them all together because it's a series. Your A being
5.
5 and your R being
1 over 5.
1 over 5. So I can find the sum to infinity. Don't let it bother you that it was from 0 to infinity. Minus 5 to infinity, it's still infinity. The determining is just where do you start? What is your A value? Right. So A over 1 minus R would then be 5 over 1 minus 1 over 5, giving me
25 over 4.
Does it sound right? 25 over 4 is 6 and a quarter, right? Okay?
Oh.
I've already got 6. And then comes fractions and less, and significantly less. Sounds to a plan. Okay, then the next question was a silly question when I looked at it afterwards. I'm saying find R. If I'm telling you what?
That is
That the sum
to infinity.
to infinity
Proof.
is 7 over
9.
9. But where do we start?
Series.
Again, write down the series. Now the series starts with R being equal to 1.
7 over 10.
So it's 7 over
10.
10. Next one,
7 over 100.
7 over 10 square, which is 7 over 100. 7 over 10 to the 3, which is
7 over
over
1,000.
1,000, etc. What was the question?
Proof that it is 7.
Find R. Find R. What's R?
It's 1 over 2.
Finish.
Oh!
That's it. We all thought, even I, when I just glanced at it, that we're going to go sum to infinity, use the formula, put it equal to 7 over 9. But then I have A. And I also actually have R. So what they wanted you to do, I think, is not put R in there and then prove with this that R does come to 1 over 10. And it does. But there's nothing wrong with stopping there and just doing that. Seeing the series, seeing the R, they asked for the R, I gave them the R, boom. I never used the fact that the sum to infinity was 7 over 9. If I want to go check with that A and R, it will give me 7 over 9. So it was not really a trick, but it's different. You don't have to do all the stuff you thought that you were going to do. So how many marks would this have?
1.
2. Always for the series, and then for the
R.
answer. If you did the long way, it's still going to get 2. Number 7 spoke about the height of an iceberg rose bush. Now, if you don't know what an iceberg rose bush is, it doesn't mean you can't do the sum. It's some sort of bush. They say the height of this iceberg rose bush is 110 centimeters. At the end of the first year, the height of the rose bush is now 120. Each year thereafter, yearly the growth of the rose bush is half of its growth of the previous year. Okay, so you're planting the bush, it's 110. Next year, it's 120. So how much did it grow? 10 centimeters. Then each year after that, the growth of the next year is half of the previous year. So what is the growth? It was 10 centimeters and then 5 centimeters and then 2.5, etc. You see it going there? Why don't I add to this the 110? It doesn't fit this pattern. Now the question is, prove that the rose bush will never grow higher than 130. So I've got to put all the growths together and see that this rose bush, what is the total? So look at the growth, just the growth. After 1 year it was 10, after 2 years it was 15. But is that now how high the bush is? No, you still got that 110 that you planted, and then the growth is added. So each year it grows a little bit less. So it grows to infinity. Technically, the rose bush is not going to always grow. But technically, there's almost no growth. And then sometimes the bush also dies. So that's the practical part of the sum. But if you want the total height of this rose bush, it will be 110 plus the growth. So I need the sum of infinity of the growth. So for the growth, I've got A equal to 10 and my R equal to a half. And I'll go sum to infinity, although I know the bush is going to die sometime. But sum to infinity then will be A over 1 minus R, which is 10 over 1 minus a half, which gives you 20. Okay, 20 is the growth. So the total bush height would be 110 plus the 20. Because remember when you planted it was 110. And usually plants do that. The first year they grow quite a lot, but then they start slowing down their growth. So that also said to me, please prove to me that this bush will go no higher than 130. I think I've done. If you really want, you can say this means it won't exceed 130 if you want to, that's fine. Okay, one thing for today, the converging series, but we spoke about this already, haven't we? What is a converging series? Like that one, it goes smaller and smaller. When you look at the growth, it goes smaller and smaller. If it doesn't, if it goes bigger and bigger, we call it diverging, which nobody's going to ask you. So the R has to be something between 1 and minus 1. So I said to you already in the previous lesson, if I say that, you hear the word converge or converging, you must immediately write down what?
The sum, the series.
Most probably you'll have a mark for knowing that it can only converge if that R is between minus 1 and 1. Alright. What is the R though? Look at this thing. What is R?
3x minus.
Do you see it?
Divided by.
That is the 3x minus 2. You don't have to put it in the bracket, but you see it? Because we take the second term and divide it by the first. We take that one, which is a bracket square, divided by brackets to the power 1, it will just give you bracket again to the power of 1. Do you agree with me?
Yes.
So the first mark actually will be for knowing that R is that and it lies between those two values. Then most probably just one mark eventually, but it's about knowing what the R is and putting it between 1 and minus 1. And then we're back in grade 10 when you did sums like these. What is this?
It's inequality.
Getting the x
In the middle.
inequality, linear inequalities. But it's a composite way of writing it. Actually, how many equations are here, or how many inequalities? There's 2. There's the one. Do you see it?
There's the other one there.
You see it? Okay. So instead of breaking it up into 2, we do it all together. You have to realize what I do on the right hand side, I'm going to do on the left hand side. But what I do on the left hand, I must also do on the right hand. So basically, if it's a composite inequality like this, I'm going to, whatever I do in the middle, also do on both sides. Grade 10. So tell me, what do I need to do? Because I'm searching for x. Right? Still solving x. So to solve this x, what am I going to do? Take the 2 across and it will become positive. And you have to write it. Couldn't I have just said 3 and plus 1? Are you with me? Okay. But then you have to divide by 3. Careful of division. When does the sign change? When you divide by negative, which is not going to happen here, but be on the lookout. If it was a negative, your signs would change around. Then if I divide by positive 3, positive 3, positive 3, then the sign did not change around. So I'm saying anything between a third and 1 will give me, if I put it in the place of x there, make that this thing will be a converging sequence or series. Right. Something just to keep in mind, if you do divide by a negative, and this does change around, and it becomes something like, for instance, minus 1 bigger, no, let's make it, yeah. Say this was my answer. What's wrong with it? Not technically wrong, but Ma'am van Skolbeck doesn't like it. We don't like writing stuff like this. We always write our composite statements with the inequality sign like that. And this should be the smaller one, and this should be the bigger one. So this is the smaller one. That's why when I swap it around, it should be there and there. If you get to something like that, please do me the favor, because if you left it like that, it's not wrong. It still means that x is bigger than negative 6 and smaller than, which is exactly what that is. It's just mathematically, it breaks my heart if it's not perfectly done. Okay. Always when you write a composite one like this, you should have smaller than, smaller than. Right. Your homework, please, on page 33 is something similar to this, so we can get to our next bit.